All right. Well, I'm glad to be here to talk about one of my favorite topics, Spring Data, and particularly Spring Data in 2023, though that's a little ironic because 2023 is almost over, but um, there's only good stuff coming up ahead. So just as a quick mention of who I am, my name's Greg Turnquist. I'm the project lead for Spring Data JPA, as well as Spring Web Services, and I'm a staff engineer at VMware. So let's get right to it. Now, so it's 2023, or well, I mean, we're coming into 2024 pretty soon here, and you want to build an app because that's what, we're software developers. That's what we do. We're building apps all the time. So usually you've got kind of a laundry list of what you're thinking about doing. What things do you need to build an app today? In particular, it's probably a web app. It's one of the most common things. It's maybe you're building client apps for smart devices and stuff, but the bulk of apps people are building, there's a web layer involved. Now, hopefully you're catching the previous session with Rob Winch talking about security. I once said it's not a real app until it's secured. So we definitely need a security layer. And some apps need a messaging. They need messaging to interact between components or with other systems and whatnot. But there's a fundamental component that I see show up in just about any application. And what is that thing that's missing? Yes, it's data. If you didn't catch that from the title of the talk, one of the big things it seems like you need is data. And if you don't have a data, it's almost like, do you have an app? There's special cases like gateway tools and things like that, but just about any app really has data. So let's dive into what the situation is here. Now, there's a lot of various databases out there, whether you're talking about, it seems maybe 20 years ago, there were a lot less choices, but now the market has opened up wide, and we have a bunch of different things. Some of these are SQL-based databases. Some of these are not. Some of these are NoSQL or non-SQL. And we have things on here like Postgres, Oracle, MySQL, Apache Cassandra, Redis, MariaDB. The one in the bottom left corner, if you didn't know it, is CockroachDB. And we also have things like MongoDB. So let's focus in on what one of the bigger ones is. And this is really kind of fascinating that even though we've had almost 20 years of NoSQL database stuff, still one of the most popular things out there is using relational databases. We still see statistics of when people come and create new applications with start.spring.io, the Spring initializer, or Josh Long's second favorite place in software land. People are still like 80% of the time picking relational databases. And when we go to that, we typically have two fundamental things to pick from. We can either use JPA, the Java Persistence API, or we can pick JDBC, the Java Database Connectivity Standard. Now, something that I've seen amazingly pop up in the past 5 years or so is this never-ending question of, what do I pick? Do I pick JPA or JDBC? I mean, how do you make that kind of choice? And I always thought of this clip from this movie. It was kind of humorous at, what am I supposed to do? Is there a clear-cut answer? And if you don't know yet, in software, everything is about trade-offs. There's no final solutions, just options and trade-offs to make. So what I want to share with you is the different options that the Spring portfolio brings to you to help you pick the right tool for your situation. In particular, we have things like Spring Data JPA. We also have something called JDBC template. This is something that's part of the Spring framework and has been there for a long time. There's actually a module called Spring Data JDBC that the Spring Data team manages that's actually built on top of JDBC template. There's something that's relatively new, about 5 years in the making, is R2DBC template. And there's also a Spring Data R2DBC. So maybe you feel that this isn't helping. We're bringing you lots of options. So maybe it makes sense to dig in and talk about what these various things are. Spring Data JPA is a toolkit that helps you deal with if you're going to use the Java Persistence API, a very popular toolkit out there that does a lot of functions for you. It serves you a lot of convenience. But you can also pick if you want to go down, if you need JDBC, if you want to write the queries yourself, we have the JDBC template. That's very there's sometimes when JPA doesn't fit your need, or you're maybe unfamiliar with JDB or JPA, and so you want to go essentially write the query yourself. Sometimes you need to write some business report, and it's a query that is 3 pages long that you need to write. In that case, the JDBC template is quite handy. And then also there's a Spring Data JDBC module, which brings to you the ability that's the Spring Data offers, which is query derivation, query by example, other tactics to help write the query on your behalf, so you can instead kind of shift your focus to the business case that you're doing. And in this case, Spring Data JDBC lets you trade in the some of the issues you may run into with GPA in exchange for a JDBC-based approach. And then finally, you can use the R2DBC thing if you're wanting to do a reactive style programming. If you're wanting to use Spring Webflux, for example, but you still want a relational database. R2DBC is a newly written spec developed in the past 5 years, and we have support for it with R2DBC template, which is like the JDBC template where you can write the query yourself, but you handle all that. You write the query and you manage the results yourself, and you let R2DBC template do the connection and resource management on your behalf. And then finally, there's a Spring Data R2DBC module. And in this sense, it provides you with the query derivation options and some of the other features that we're going to talk about a little bit later in this presentation. So you have a lot of options to pick from in order to pick what best fits your needs. Now, I'm going to focus in here on what are some of the new things that we're working on with respect to Spring Data JPA, what we've added in the past year. Well, one of our biggest developments is we now have a HQL and JPQL parsers. That's the Hibernate query language and the JPA query language. And actually, this deck is already out of date because we recently added support for EQL as a parser. That's the Eclipse Link query language. So in case you didn't know, there's a JPA specification that's managed by the Jakarta EE team, and it specifies what a JPQL query looks like. However, the Hibernate team has essentially an extension or a superset of that language with additional options to write queries, and that's what the Hibernate query language is. And then EQL is Eclipse Link's extension of the JPA standard for writing queries, and we support all of those. So if you're wanting to write if you want to write the query yourself, but still use the Spring Data JPA repository solution, you can add a method to your repository definition and use the @query annotation and write it yourself. This gives us the ability to tweak and manipulate and alter the query, so you can write a bare query, but we can provide some additional arguments to it. We also have a new feature coming out in the entire Spring Data collection of modules that we support called keyset pagination. This is a feature which I'm going to go into a little bit more here that lets you have a bit smarter way to scroll through result sets. So it's not such a one-size-fits-all single approach to it. It gives you a lot more flexibility. And finally, with the rise of GraphQL popularity and stuff in various APIs, we actually have support in Spring Data JPA to write queries and iterate through result sets in a style that lets you support GraphQL. Now, in the land of Spring Data JDBC, we have some new stuff provided, and I've got some screenshots coming up here. One is we have support for Schema Generation. This makes it possible to something that you kind of get for free with JPA is that JPA provides support for generating the schema based upon the entity types that you define. When you go into Spring Data JDBC, it's not quite as straightforward as that. It's a little bit simpler. Now, sometimes in a real production system, you may not create the schema yourself directly anyway. A lot of times the DBAs may manage the schema definitions for you. But in this context, you can use the Spring Data JDBC to generate your schema and then use that to give you a leg up to get going. And one of the other new features that has recently been added to Spring Data JDBC is something called single query loading, which I have a lot more detail coming up, as a more sophisticated way to write to solve the N+1 entity loading problem. Now, this code fragment here is what the schema generation support looks like at a glance. In this sense, if you have an entity class like called a minion, you can define here a collection, and it lets you say, okay, in the context of this is the entity type that I need the schema to wrap around, and you're wanting to use something like liquid base to manage changes. This gives you the ability to go decide how you're going to respond to that, and essentially this will let you generate change set files that Liquibase will then consume. If you're unfamiliar with it, Liquibase gives you the ability to basically capture changes to your database schema so that as you evolve your schema over time, you can capture these change sets along the way. So you actually can put change management of your schema under version control. And this gives you the tools to not have to do it by hand per se, but to do it in a more programmatic fashion. This is actually what a change set file looks like that the thing can generate out of that. And there's some various strategies here. Now you could go write the file yourself, but the whole point is to leverage the information you can get out of the entity types. And also, if you're in Spring Data JDBC, you have access to the annotations that Spring Data Commons provides for marking up your entity types. And then the schema generation feature can take advantage of that. So, something else I want to mention that's a big addition that has joined the scene in 2023. It's the fact that we have observability. The Spring Observability project has emerged, and we definitely have support for that. One of the most important things you're going to do if you're going to build an application is not only are we going to recommend pick up Spring Data to help you do the data operations that you need to support your application, but if you want to use a toolkit like Micrometer in Spring Observability's portfolio, you can manage what is happening. You want to know what queries am I building, and how are they performing? How are they acting? Which query is spending the most amount of time? And when you combine them together, this is what gives you the ability to monitor your application in a realistic way. With Micrometer, you're able to then bridge into various tools, whether or not you use the OTel format or not. You can then connect to a dozen different tools to gather the metrics. And a lot of times, if you're building, I mentioned earlier about you're writing that monthly business report, that the query's 3 pages long, it joins 20 tables together to get the results. That query, the other queries you're building in the system, by monitoring all of them with Spring Data's connections into the system and monitoring all the queries, you can quickly go figure out which query is eating up all my time, which one's consuming my database's budget, so I can go figure out which one I need to optimize first. And that's vital important. So you're like, okay, that one's eating up 35% of my database. Let's fix that one first. Now, if you want to add Micrometer to your app, all you have to do is make sure that you've included Spring Boot Actuator, the Spring Boot Actuator starter at the top there, and the Micrometer tracing. In this case, this example, I'm using the Brave engine, but there's actually multiple bridges for Micrometer to hook in tracing, in this case to connect to Zipkin. But you can actually find this stuff when you go to start.spring.io to make sure you're up to date for whichever you're trying to bridge in. Again, this example shows Zipkin, but Micrometer, we actually have support for multiple observability collection engines. Now, again, what do you get by adding Micrometer to your system? You get to track critical information, such as what happened, exactly what query was issued against the database. When did it happen? This is part of, you get to track the timestamps of when various events happen. More importantly, how long did it take to happen? And another key facet is it's not disparate, single item events to go. You have to figure it out. They're actually chained together in multiple observations throughout the system. So, for example, the Spring portfolio supports, for example, if you use REST template to make a remote call, the REST template is going to hook in, and if you've activated the observability support, will track those remote calls. What time is being spent on remote calls? The same thing is if you have a web call coming in through a Spring MVC controller and then you hit a Spring Data repository, all that's going to be linked together so you can see which web request resulted in what database query and how long did the entire interaction take. But if there's anything I've seen in observability systems throughout my career, it's the fact that sometimes when you turn on these systems, you can actually overload the system by gathering too much data. So that's a risk that you have, and that's why by default the actual Spring Boot, when it auto-configures Spring Observability, actually configures it to only track 10% of actions. Okay, so only the 10th interaction that I just described of Spring MVC route invoking the Spring Data repository method is actually going to be logged into the system. That's adjustable. You can switch it to, I want to move it up to 100% to make sure it's working. So I want to observe every call, or I need to scale it back to 0.01%, something like that. You can pick what level you're doing so you don't put too much congestion onto the system. Now, if you want to add Micrometer to a relational app, if we're talking about either Spring Data JPA or Spring Data JDBC, then all it takes, so the previous segment that I showed where I had the stuff to add on for Spring Boot Actuator as well as Zipkin, that was just in general to add the observability support. If you want to then activate it for a relational app, all you need to do is add this one dependency, data source Micrometer Spring Boot. And what does this thing give you? Well, basically it works with any data source based tech. And that's why I mentioned JDBC and JPA. Essentially, that's a wrapper that wraps around the data source, any data source being that's in your application context. Data source is used by JDBC template. The data source interface beans are used by Spring Data JDBC. And you may not know this, but actually data source is used by Spring Data JPA. That really works. So any one of these things are still sitting on top of data source. And that's because you may not be aware, but Spring Data JPA, well, JPA in and of itself leverages the JDBC stack to do its heavy lifting. So JPA generates queries and leverages JDBC, so hence it works. I apologize, I have a lingering comment here that's no longer relevant. So that's how to add instrument observability to your application. Something else that's the Spring Data team has been adding this year is been to generate a better way to scroll through data. Because if there's anything that's true, it's that our apps have lots of data, but we can't look at all of it at once. So for years, we've had support for something called Pageable, but now we have a new feature called Scroll Position. Now, what is this applicable to? Well, what we have introduced is what's called a scroll API. And here I have a sample chunk of code, okay? So here's a sense of, we're going to run some query. Like this is I have this query, find by last name. Look up in anybody that has the last name of Baggins. And I want to iterate through all the users of that thing. But instead of getting back a page of data, I'm actually going to get back a window of data. A window of data gives me, in a sense, like a chunk of data, a set of users that I can iterate through. And then I want to get the next window and iterate over them. And then the next window after that. So here with this given window that was fetched as part of our new scroll API, I can now iterate over these users and like print them out or something. However, then when I'm ready, I can then fetch the next one. So I can go grab, give me the next window of data and then do it all over again until as long as it's not empty and as long as there is a next window coming, then I can go do that all again. Now, that's not the only way to do that. There's another thing we've added to the thing called a window iterator. And this is applicable to all the data storage you can see on the left-hand side. This essentially says, I want to grab a window of data. I just want to iterate over the users. And you handle when it goes and fetches another window. So it's almost like a continuous scroll. And what's the benefit of this? This lets us fetch a window of data. Fetching it by the window instead of grabbing it user by user by user is a more efficient way to interact with the database. Go out to the database, grab a chunk of data, bring it back, and iterate over it seamlessly. Now, why did we do this compared to the pageable solution that we had in the past? Well, immediately, it's more efficient. So the formats we have are both, one is called offset-based scrolling. And what offset-based scrolling essentially does is it alters the query by applying limits and offsets. So essentially you're saying, run the query, but only give me 10 rows at a time, for example. And when you do an offset, it says jump ahead by, 100 rows, that kind of thing. And in the olden style, when you said, give me a page, you said, my page size is 10 and I want the 20th page. So it just does the math. 10 times 20 is 200. So essentially it jumps ahead to the 200th position and then grabs 10 rows. So if you were to go and grab 10, iterate over multiple pages, and you're like, okay, I got 10 this time, but I want 20 next time. Well, you can't change the number like that because your calculation for your offset was 10 times 20 or 200. And so to change the page size would require starting over from scratch. The scroll API has a more sophisticated computation, so it can just jump to the right point, and then from there you can say, now I want to scroll to the next to 20. Instead of scrolling to 10, I'm going to scroll to 20, and it can just jump from there forward. Now there's another implementation of the scroll API called key set based scrolling that I had mentioned earlier in the presentation. So key set based scrolling lets you take advantage of indexes and sorting to retrieve sorted query subresults. What that means is it's able to write a more efficient query. So instead of when I say I need to jump, I'm going to pull this query down and I need to jump to the 200th position. In the simplest calculation, essentially it pulls down 200 rows and throws them away and starts at position 201. But with key set based scrolling, it's able to leverage the indexes related to the entities that you're querying and instead provide that as extra data in the criteria that you don't have to deal with. Excuse me. And then as we looked at, we were able to see how to iterate. Either you control the window or you can delegate that to the toolkit to do it for you. And again, it lets you, by all this new API that we've tried to make as simple to leverage as possible, you can change the size of your request as you go. And there's no need to, per se, go back and restart the whole query and then figure out how to get to your position. In fact, there's even support for going backwards. You can scroll forward however you like, and then you can change course and go the other way, either explicitly or there's a reverse operation. Now, here's an example of doing a key set based scroll. And in this case, the query says, find the top 3 by first name, starting with order by first name, ascending, email address ascending. So essentially grab a window of data, and then do something with that first window. But then when it's time, you can go grab the window and jump ahead to 2 spots. Now, you can also signal here. So you built your scroll position, but you're also giving the signal of, I want to navigate in the other direction. And so it makes it easy to turn around and go the other way if that's what you need to do. This makes it a lot smoother if you're trying to build a UI on top of this and the user's wanting to scroll down, and then the user wants to, at this point, change from 10 to 20 as the size and keep scrolling. Or if the user wants to scroll up, you can then integrate that with your query and give them a more dynamic experience on their web page. Now, we also have some improvements in the land of NoSQL. So, I talked about how on the order of 80% of apps today are still leaning on SQL-based relational databases. While that's true, there are large systems out there leveraging NoSQL stuff. So, I mean, it's not a left-behind technology. It's whatever you need to solve your problem. So in this context, let's see what we've got here. One of the biggest ones here is the most popular ones is called Spring Data MongoDB. And a feature that MongoDB has recently added is encrypted fields. Essentially, in certain values, while you're transmitting it from the client over the wire to where the MongoDB instance lives, you can have the ability to encrypt them on the client side. And so we've added some annotated support where you can sit there and mark up which fields need to be encrypted. And that way the toolkit can handle making sure that they're secure while they're traveling over the wire and also when they're being fetched back. Now, another feature that we've added is bulk reactive operations. So this one is not as commonly used, but it's the ability to sit there and say, I need to do this bulk operation that I'm gonna insert a whole flux of people, and I'm going to insert into the people table, and I'm going to do this update. In this case, it's doing a where operation, and it has execute. But again, in case you forgot, with reactive solutions, nothing happens, no connections are created, and the bulk operation doesn't happen until somebody subscribes for the bulk write result object that comes out of that. So that's support for when you need to do these kind of updates to your app. There's also some more stuff like support for correlated subqueries. In this context, you have you're doing a lookup operation, and you're wanting to do this little pipeline thing down the middle. This gives you the ability to hook in and use some of MongoDB's more sophisticated operations. Now, don't quote me because I'm not an expert on MongoDB, but they have some very sophisticated operations to pipeline stuff and interact with the documents that you have stored in there. Now, some of the things people are always asking, like, what's the future of Spring Data? Like, where is it? Where are we going with this, or what's coming? And so I wanted to tackle a little bit of that here. So Spring Data 2023.1 is the official Spring Data Next release, or the best way to decode that is this is the version of Spring Data, the release train that supports Spring Boot 3.2, which is just around the corner for reaching GA status. Excuse me. And some of the key features that Spring Data is adding in support of that includes Kotlin inline value classes for persistence operations. So Kotlin has this ability to say, okay, take this value class, the email object at the top, and put the JVM inline annotation on it. That means the email object can then be used in a Kotlin data class like a normal type. And it's something that's really handy for application developers, so you can put things into logical structures. If you peel back the curtain and look at what Kotlin does under the covers, from a JVM Java perspective, it's really complicated and cryptic. So the point is that we've added support for Spring Data to handle this scenario. So this can be your data storage type in any Spring Data module. So long story short, handy for you if you're a Kotlin developer, this is now an available option in the Spring Data Next release train. Just something that took us a bit of effort to implement it properly. Now, there's something else that we've had in Spring Data for quite some time, the ability to write top queries. I showed it on an earlier slide. You saw like find top 3, where you can sit there and say, it's like fetching the query and only holding the first 3 rows of the result. Well, that kind of bakes it in hard that query will always get just 3 and 3 only. There's now a new value type called a limit object. And you can see in the middle of the screen, it says limit of 10 or limit.unlimited, or you can make it where you're feeding that, or you can connect that number to what the user puts in. So you could put a radio button on a web page and the user can pick 10, 20, 30, and you'll turn around and feed it to this. And you only need to write one custom finder here and feed it that option. So this gives you more flexibility, and it saves you from having to write a separate custom finder for each of those radio buttons, for example. This too is available in all Spring Data modules. Now, we've added additional support to Spring Data Relational. Spring Data Relational, by the way, is the module that houses both Spring Data JDBC and Spring Data R2DBC. They share a common engine for doing the SQL generation activities to support Spring Data operations. Spring Data Relational has added spell support for both the @table annotation and the @column annotation. And just to be extra clear, this is Spring Data's @table, @column. This is nothing to do with Spring Data JPA and JPA's @table or @column annotation. And if you look at the code itself, it lets you put a spell expression like # my tenant controller.get person table name. This is a way you can implement where you could have multiple applications, instances of applications running, but they're all in the same database. And so you need to have, each app needs to have a tenant ID in a sense to be able to pivot to exactly which table name. Is it app one's table, person table, or is it app two's? It gives you the ability to make that more dynamic. And the same for the column name. Now, Spring Data for Cassandra has a Cassandra scroll position wrapper for the scroll API as well. So we're going data store by data store to add scroll API support. And currently, I believe we have it in Spring Data JPA, Spring Data Neo4j. I think it's in Spring Data Relational, but I'm not 100% certain on that. And then this is to show you that we're also extending it to Spring Data for Cassandra. Now, there's also for those of you that are using Redis. Redis is a blazingly fast key store thing, and it has various functions and pipelines and stuff like that. The Redis list type from Spring Data Redis has aligned itself to support Java 21, the sequenced collection type. This is a new container or iterable type that's in Java 21. And one thing that Spring Data Next does is it's based on Java 17, but we also test in our continuous integration setup. We test against Java 21 to make sure that there's no surprises or breakages or anything of that kind. And so we do have alignment support for that. Now, something that's coming that's a big development feature in the entire Spring portfolio is the crack support, or is it the check restore? Now I can't remember what the check restore feature. Anyway, there's a coordinated restore checkpoint. It's written right there, of course. So this is where your application, they can basically snapshot your application and then you can restart it at that point in time, if you will, kind of like taking a screenshot of a virtual machine. And so for this, we have to add a little bit extra support to be able to handle things. For example, the Redis connection factory has now been dubbed a lifecycle bean so that Spring Data Redis can support that. And we're going module by module to see what other tweaks we need to make to support the coordinated restore checkpoint feature, to again give you more options for start up your app, snapshot it, and then from an operational sense, be able to start up amazingly fast in that situation. Really handy, for example, you need to run 100 instances of that app and to have that, be able to skip all that startup time. Now, there's some other stuff here as well, like for those using either Spring Helios, there's a slice model, if you didn't know that. We've had pageable, we've added the scroll position thing. We also have what's called a slice, which is sort of it's like a page, but a page without the offset. So if you actually return a slice-based result, there's a slice-based hypermedia type, a sliced model, if you will, in Spring Helios. So this makes it smoother for you, and if you're using Spring Data REST, to sit there and define return types if you're supporting that. And so all this stuff, when you add it up, it's to demonstrate that this ain't your grandpa's Spring Data. And instead, Spring Data 2023 is the way to the future. Now, if you're wanting to try to decode this, if you go visit, you can go figure out what is what. If you go visit on GitHub, Spring Projects, the Spring Data Build Project, if you look at the top, there's a wiki page that shows each release train. And if you look at the top, you can see the name. Now, I mentioned it earlier in this presentation that I was talking about release train 2023.1, the official one. But if you look, let's move the little arrow over here. I was talking about this one. And the way to decode that is to look at the little bit underneath there and say, this is the version that works with Spring Boot 3.2. You can see all the modules below it and their status on CI. But more importantly, if you click that hyperlink that arrow is pointing to, you can access the release notes and see what exactly is in this version of Spring Data. And in this case, you can see some of our initial support for virtual threads through executor configuration. I mentioned Java 21 compatibility, Kotlin value classes, and the checkpoint restore feature. And you can go scroll down. I don't have it all on here, but this makes it possible for you to check stuff out and to figure out what's in this version of Spring Data versus what's in the other release trains for Spring Data. Now, here's a bunch of links here we can get access to the Spring Data project itself. If you go to spring.io/projects, you'll find it on the list. Some of the big stuff we talked about here was Data JPA, the Spring Data JDBC and R2DBC projects. Now, to help decode some of this stuff, we talked about JDBC template. That is part of Spring Framework, and that is in Spring JDBC. So don't confuse Spring JDBC with Spring Data JDBC. So in Spring JDBC, you can click down there in the reference documentation to learn more about things like JDBC template. The R2DBC template initially started as part of Spring Data R2DBC, but several months ago, maybe it was a year ago, we actually migrated it to the Spring Framework. That does happen on occasion. Something that's rock solid like that can be folded into Spring Framework. So there's now a Spring R2DBC module, and you can go check it out in the reference documentation. And if you're kind of new to the whole concept of R2DBC, then I'd suggest you go visit r2dbc.io, which is the home for the R2DBC spec. That's the reactive relational database connectivity specification that debuted in 2018, and we've been working on since. You'll find that there's support there for things like Postgres, SQL Server, MySQL, and other data stores and such and such. And so finally, I'd like to say thank you for tuning in, and I'm going to exit my screen sharing mode just to see if we've gathered up any questions.